So I have another story problem, and I like to do these because it helps you to visually see what's going on and then actually do your own problems in your homework. So now I'm given 120 feet of fencing, and I need to wrap this around basically a rectangle to enclose an area. So I have a rectangle, and I know that there are two sides, and I know that the sides are different. So what I decided to do is I want to make the length x and the width y. Since I don't have any numbers, I've just got this x and this y hanging around. Now, how do you find the perimeter of a rectangle? Well, P equals 2 times the length plus 2 times the width. And what do we know about that distance around? Well, we know that we have 120 feet. So the most that our perimeter can be is 120. So I've got 120 equals 2x plus 2y. Now, I need to solve for y. That would give me a function, right? And so what I'm going to do is I'm going to divide everything by 2 first, because I noticed that everything's divisible by 2. So I'm going to get 60 equals x plus y. Now I want to get y by itself, right? So I'm going to subtract x from both sides. That's going to give me 60 minus x equals y. Okay, so that's my expression in terms of x. Now, if I'm going to maximize it, remember what we did before. If you're going to maximize it, you're going to have to multiply. And I know that because remember the area, that's our key word right here, area, A equals the length times the width. If I already know what y is in terms of x, then this is going to be x times 60 minus x. And I want to go ahead and I'm going to distribute that, so that's going to be 60x minus x squared. So that's your area for maximizing. Now, I want to turn it around so it looks like the equations that we've already done. So I need the x squared to come first. If you still want to hang out with a c and put a 0 there, please do so. If you don't, you can just kind of ignore the 0. Now, we know that with the minus in front of the x squared, that this parabola opens down. So therefore, we are going to have a maximum value, which is exactly what we're looking for. So what we want to do is we need to find the vertex. So to find the vertex, remember x equals the opposite of b over 2 times a. So I'm going to have 60 negative over negative 2, which is going to give me 30. And then to find the y value, I'm going to plug that value into my formula. So I have y equals 60 minus x. Remember, maybe I should have color coded that. That's way back over here. And now I know that x is 30, so 60 minus 30 is 30. So my vertex is at 30, 30. Now that's half the battle. So we've got the numbers. Now remember, we wanted to find the maximum enclosed area. So again, what we need to do is we need to find, okay, that formula for area, that's right up here. And that says that I'm going to multiply x times y. Well, if x is 30 and y is 30, I'm going to multiply those two together, which is going to give me 900. So it's going to take, it'll be 900 square feet is how much that would maximize. But remember, it also asks for the dimensions. So you really need to have all the information to answer the question.